Welcome, everybody. Thank you for joining us. My name is Chris, and I'm going to be hosting this webinar today. I've been working with IAC for a very long time, close to a decade, and so I'm familiar with, familiar very much, obviously, historically with Terraform, and now with OpenTofu. I'm also the co-founder of MassDriver, who's hosting this webinar. For those who aren't aware, MassDriver is a visual platform that allows you to package, distribute, deploy, and even visually connect your IAC modules. So it works for OpenTofu, it works with Terraform, works for Helm, as well as a lot of other IAC tools that you may be using. During this webinar, please don't hesitate to ask questions. In fact, I'm going to swap over here so that I can see chat. If you guys have any questions, please ask them. I will answer them on air. We also have some coworkers that are in the backstage that can also try to help if there's any questions that I can't take here on air. So today, what we're going to be going over is getting started with OpenTofu specifically on AWS. Which is where I have the most experience, though I've worked across all three clouds. This demo is going to be specific to working in AWS. So I'm going to be linking in chat. There is a GitHub repo that has a lot of materials to go along with the content here that I'm going to be using. So feel free to clone that, and you can follow along yourself. You also obviously are going to need OpenTofu, so I'm going to share a link to the OpenTofu website and specifically the docs around how you can install OpenTofu. So with that, let's go ahead and get started. So let's kind of go over some of the stuff we're going to talk about today. So first, we're going to set up OpenTofu. We're just going to use throughout this whole thing, this whole webinar, we're going to be using actually the same module, and we're just going to use it for a few different things. We'll go over what a state file is and why it's important to OpenTofu. We're going to configure AWS S3 to be our remote storage for state. We'll also talk about why that's important to use remote state storage. We'll look at how you can use importing in OpenTofu to manage existing cloud resources. It's also the same process that you would use if you needed to recover state. If for some reason your state became corrupted or lost, we'll talk about importing, and it's a way to basically, for existing resources, convert them that aren't managed by OpenTofu, convert them into being managed by OpenTofu. We'll go over some best practices, just some very high-level best practices for building and running OpenTofu. But if you check out that repo, we actually have a whole lot of, like a much larger list and fairly detailed about how to manage, run, design OpenTofu. So check that out if you're looking for some best practices. And then I'm shamelessly going to plug MassDriver. I'm going to show you how you can use MassDriver to deploy and package and distribute OpenTofu modules. So with that said, most of this webinar is going to be hands-on. So let's actually jump into a terminal here and start working with some code. So I'll make this a little bit bigger. So I've already downloaded the repository for that I linked earlier. That's also in the banner. We're in it right now. We'll get to that in a sec. First, make sure that OpenTofu is actually installed, which I also linked instructions for that earlier. So you can check the comments. But if I do Tofu version, you'll see we have OpenTofu. It's version 1.8.1, which should be the newest version as of at least a few days ago. And so we're ready to rock and roll. So I'm also going to, I believe I actually already have it open, a VS Code with the webinar, which is exactly what we want. There we go. VS Code. This also. So I just have a VS Code window open to that webinar, the GitHub repo with all the webinar details in it. So that's what I have open right here. So if you have that cloned locally, you should be seeing roughly the same thing. Like I said, if you want to check out best practices, please go ahead. You can read that whole thing, though it's going to be easier to read this markdown out in the actual GitHub repo. So let's actually take a look at what is in the OpenTofu directory, because this is going to be where all of the OpenTofu is. Let's start actually in the main.tf. This has all of the stuff that we're going to need to provision resources and what we're going to be using throughout this webinar. So when it comes to OpenTofu, there's kind of 3 core types that you're going to be working with. There's resources, and resources are going to be things that you're going to be creating or managing. So in this case, we have an S3 bucket, some S3 configuration resources, and then a DynamoDB table. So there's 4 resources here, but realistically, it's only really kind of 2 resources. It's the S3 bucket and it's the DynamoDB table. A few years ago, they moved to kind of separating out the configuration of S3 buckets into separate resources. But these are just configuring the S3 bucket. Specifically, if you're curious, this is making the bucket. This one down here is disabling any public access to the bucket, which is generally what you want to do. Very rarely do you want your bucket to be open to the public. And then this top one right here is disabling ACLs, which are access control lists. It's basically making it so that the bucket is entirely managed with IAM, with AWS IAM rules. And so it's getting a little bit into the weeds, but the main thing you need to know is we're just setting up a private secure S3 bucket and then setting up a DynamoDB table. So that's those are excuse me, I have a sneeze coming. Now it left. Okay. These are resources. This is when you can create stuff. The other thing that you'll sometimes see that looks similar are called data blocks. What data blocks allow you to do, it doesn't create anything. A data block, and it would kind of look like this. You'd have, data, AWS S3 bucket, and we'll just call it foo. And inside, you're going to have something to identify it, probably something like bucket name equals, and then the name of the bucket. What a block like this does is it goes out and looks for an existing resource and pulls down configuration. Now, we're kind of starting from scratch, and so you don't really have data blocks usually in something like that. Where data blocks become valuable is, for example, if you're deploying like a database and you need information about the network or the subnets that you're deploying the database into. You can use a data block to go look up information about other resources like subnets, VPCs, and pull that information down so that you're not having to pass it in. And so speaking of passing it in, the other thing that you'll see a lot is variables. Variables are the way that you specify, hey, here's the configurable inputs to this module. And so in our case, we have what we want the name of the bucket to be and what region we want everything to be deployed into. So this is the way that we write up our configuration, and variables allow us to change how that configuration will end up getting deployed. You can see we use that right here when we're naming the buckets. We use the variable called bucket name. And same thing when we're actually making the DynamoDB table, we are using the bucket name and just adding this -lock, because that DynamoDB table is actually for state locking, but we'll get to that later. Similarly, for the region, we actually set that up in the provider block, which we'll get to in just a second. The last thing that you'll see is outputs. What these outputs are for is, one, if you're running OpenTofu locally, it will write these things to the screen. So if you want to get specific information out, like perhaps the bucket ARN or the DynamoDB table ARN, you can create outputs like this. The other thing outputs allow you to do is, if you're packaging up modules together, these outputs are then referenceable outside of the module. So you can create them, and we'll probably see this a little bit later. You can create a module and then you can reference the outputs of that module, for example, to pass into another module or just in other resources within there. So that's where outputs come in. The last piece that you'll see here is this. You have a Terraform block. This is where you're going to be configuring OpenTofu itself. You're going to be setting which providers to use, which versions of providers to use, and configuring providers themselves. And in this case, it's a fairly bare bones configuration, just the region. But the AWS provider wants you to set region kind of at the top level, and then it will use that region throughout the rest of the provisioning. So that's the structure. And it really isn't that complex. This is a very simple module. And just make sure OpenTofu is working. Let's go ahead and actually try to deploy this module as is out into our AWS account. So I've set up my AWS credentials already. If you haven't done that, obviously you're going to need AWS credentials, and you need them locally if you intend to run OpenTofu locally, which I already have. So the first thing is we need to actually CD into that OpenTofu directory where we have all of the OpenTofu configurations, and we're going to run tofu init. What this is going to do is it's going to look at the configuration that we have, and it's going to pull down any providers that we need. It's going to set up state, which we're just using local state right now. We'll change that out later. But it's going to basically set up everything that we need to be able to actually execute OpenTofu. And there we go. It's telling us that we're ready to go. So now we can run tofu plan. And what plan is going to do is it's going to look at our configuration. It's going to look at state, and it's going to look at what's deployed, and it's going to come up with a plan for the changes that need to take place for our desired configuration to happen, to be realized. And in this case, we have to create all four of these things. We have to create the DynamoDB table, as well as the bucket, and those two configuration resources onto that bucket. So what I actually want to show you here is I'm going to run tofu plan again. But what I'm going to do is I'm going to tell it to output the plan to main.tf plan. So what this is going to do, it's going to run that exact same plan again, but it's going to write that out to a file. So now if I do an ls again, you'll see we have main.tf plan right here. This is useful, particularly in automation, because if I were to just run apply is actually going to generate a new plan again to execute. But apply can take in an existing plan. And so this is a common way to do it, especially in automation, is you run a plan and you output that plan that you just ran to a file. So you have kind of a frozen example or a frozen set of directions of exactly what OpenTofu wants to do. And that's what we have with this main.plan, which means that now we can run tofu apply. We can pass it that plan that we just made, main.tf plan, hit enter. And it's going to go out and do it. It's going to create the bucket. It's creating those configuration things on top of it. And the last thing it's going to do is create the DynamoDB table, and it's done. Quick and easy. Oh, it's like 5-10 seconds, and we've now created all those resources. So we have an S3 bucket. We have the DynamoDB table, and clearly we have OpenTofu working locally. So in the most basic use case, that's how easy it is to use OpenTofu to deploy and manage resources. We can actually check and see that S3 bucket exists. I also have the AWS CLI here locally. If I do AWS S3 ls, and then we pass it the bucket name, I believe it was webinar OpenTofu on AWS. And it's empty right now. So if I would have misspelled it, it would actually error and say the bucket doesn't exist. But the bucket does exist, and so it's just empty. So when we ls, we get nothing back. But since we didn't get a doesn't exist, we've made that bucket. That bucket's out there, and it's ready to go. So we have it working. But the situation that we're in right now, if we ls, is we have our state locally. That's what this terraform.tf state is. And that's not great. And so let's talk about that a little bit. In fact, let's jump back to the slides. Let's talk about what state is, why it's important, and let's also talk about why you probably actually want to be managing your state remotely. So, what is state? Well, one of the best features about OpenTofu is the ability to declare the resources that you want. Let's say down the road, you no longer want one of those resources. Let's say that I actually changed that configuration that I had and I said, I don't want that DynamoDB table anymore. It's unnecessary. I can delete the DynamoDB table from that configuration. And the next time that I run OpenTofu, it will recognize that the DynamoDB table previously existed. It no longer exists in the configuration. And then it can basically assume, okay, I need to delete that table in order to go from what it was previously to what it is, what you desire it to be now. That's really what's the biggest thing that state allows you to do, is it keeps track of what was the configuration after the last time OpenTofu ran. And that is crucial for being able to figure out resources that need to be deleted. And that's a big differentiator, actually. Let me shamelessly plug very briefly the Platform Engineering Podcast. And the reason I bring that up is on the podcast, which is hosted by the CEO of MassDriver, Corey O'Daniel, he met with Mitchell Hashimoto, who's the creator of Terraform. And he was talking very briefly in the podcast about state. And when he was trying to sell the idea of Terraform to these organizations, this is very, very early on. One of the questions, after he gave the kind of the whole song and dance of why this company should use Terraform, there was one question that somebody raised their hand and basically asked, will it delete resources? And Mitchell was able to say, yes, it does. And they said, I'm sold. And so it's a very valuable thing to be able to create configuration, modify it, including removing resources from that configuration. And because of state, Tofu can look at it and say, well, this previously existed. It no longer is a part of the configuration. Therefore, I need to delete it. And there's no real easy way to solve that problem without something like state. So that's why state is important. So what do we do with it then? So by default, OpenTofu state is going to be stored locally. We just saw that. It's that terraform.tf state file that exists in the same directory as the module. This isn't ideal for a few reasons. Number one, that state file can actually have secrets in it. It can have sensitive information. You know, if you're creating a database, for example, an RDS database, one of the things you have to pass to the resource configuration is the password. And so that is going to get stored in the state file. And so you don't generally want secrets like that stored locally on your employee's computer. So you don't want secrets. Number two, if it's local like this, you have the risk of potentially deleting it, modifying it, corrupting it, something like that. The more people have direct access to the state file, the more likely it is that something accidental will happen to that file, like deletion or modification. Number three, this is a big one, is that if the state is local, you can, if you're in a collaborative environment, you have multiple people that could be running OpenTofu. State needs to be modified like one at a time. If two people attempt to modify the state at the same time, you end up getting diverging state or broken lineages. And this becomes a very, very big problem, because if you have two simultaneous executions, so for example, let's say you and a coworker both, let's say you check your state file in to your local repo with your OpenTofu config, and you have two employees, they both pulled it down, they both attempt to run OpenTofu. Both of those OpenTofu runs are going to modify state. When they both try to check in those changes, there will be conflicts, which is annoying. But more importantly, you're going to have broken lineages because two different changes happen simultaneously. And OpenTofu really, really doesn't like that. And so when you move state remotely, you can put locking around it that ensures that changes never happen simultaneously to it. They only happen one at a time. And you don't really have to worry about checking it in or anybody, accidentally making mistakes with it. So that's a big reason. The last thing is kind of a subtle one. If you have state locally, it kind of implies that you're probably also running your OpenTofu locally, and it's best to not be executing your OpenTofu locally. If you can move it into automation, CI/CD, that's always a better way to be executing it, because if you're executing locally, it also means that you likely have root credentials to whatever environment you're deploying it into, which is also not a great situation to be in. So those are all the reasons why you should be using remote state. So let's now go back to that configuration that we just had, where our state is local, and let's move it into remote state. So let me reopen VS Code. And luckily, right here in the provider's configuration, I've already pre-filled a backend configuration for managing the state in S3. So this backend is telling it, this backend block is telling Terraform where to manage state. We're telling it to manage it in S3 or to use the S3 backend. And these are the configuration values. There's many more. You can go look at the documentation. There's a ton of possible configuration values you have here. These are kind of the crucial ones, I would say. This is a fairly bare bones configuration. First, you have to give it the bucket name, which normally you should not be variabilizing the bucket name. We're variabilizing it here because we're kind of doing a chicken and egg thing, where we provision a bucket and then we're going to use that bucket that we just provisioned it to store the state that we have. And this likely isn't a common scenario, though it is if you're first getting started and you have this. But you almost always are going to want this bucket to be probably like a hard-coded value, maybe variabilized if you store state, in different environments, like a production state store and a staging state store. But it shouldn't be variabilized to the module. You don't need separate buckets for every single module that you're running. You should likely just have one bucket, or at most one bucket for an environment. This key should be hard-coded like this. This is going to be the path to where your state is. So this is also going to need to be unique for every module that's executable. Every module that you use to run OpenTofu, you're going to need a separate key of where to store the state, because you don't want to be overwriting your state of different things. And granted, OpenTofu will likely try to stop you from doing that, or at least warn you. But this needs to be unique. The region is going to be the region of the bucket, which again here is variabilized, but likely shouldn't be variabilized. It should be fixed to whatever region this bucket is in. And then the last thing here is the DynamoDB table. This DynamoDB table is for state locking. So FYI, S3 buckets don't really have a locking mechanism. Two things can be writing effectively simultaneously to a file, an S3 file. And so what this DynamoDB table does is the separate resource that Terraform uses for state locking. So when you start modifying the state, it will write to Dynamo and say, hey, this thing is locked. So that then if somebody else tries to run, it will see that the state is locked, and it will halt immediately and say, I can't run. OpenTofu will say, I can't run until the state is unlocked. And so then once the existing OpenTofu run finishes, it'll remove that locking record from DynamoDB, and then other OpenTofu executions can run. And so that's what the DynamoDB table is. You may hear that and think, how often is that going to happen? We're never going to have two people trying to execute at the same time. If you're an engineer, you should already know that if something happens 1% of the time, eventually it's going to happen. Eventually it's going to happen. And when it does happen, it's going to be very, very painful. And so I've already given you the configuration for the bucket in the DynamoDB table. Just use it. I promise you, it could eventually save you. It'll add 5 minutes now, and it'll save you many hours down the road when inevitably two people attempt to execute the same OpenTofu at the same time. So now that we've added this backend configuration, it's actually very easy to get OpenTofu to migrate the state from being local to this new store. So let's jump back into the terminal, and we actually just run tofu init, and then we give it this argument migrate state, because tofu is going to immediately recognize that the state has actually changed. So if I just run tofu init, it's going to be very angry. It's going to, oh, I'm actually surprised. I'm surprised it did that. Usually it'll look at it and say, hey, the state configuration is different. Let's go migrate state. I actually might need to, let's try this, tofu init migrate state. Let's look now and see if I do tofu plan, is it going to try to create everything? No. So that tofu init migrate state ended up taking the local configuration that we had, and it moved it out into S3. At least it should have. Let's double check and see in case I mess something up. If we do AWS S3 LS, and then we check that the bucket where this all should be, we said the name of it was webinar OpenTofu on AWS. And then it was path to, I think it was something like that. Let's look and see. It isn't out there. So it might still be using, maybe I didn't save that configuration after yeah, I didn't save it. That's the problem. So if I save it now, it's going to, that was probably why that first tofu init didn't show any issue. So we haven't done anything yet. If we do tofu init, this should likely error. See there, it's saying that it's recognizing that the state has moved. It's actually asking us if we want to migrate from our local backend, the local state, out to the remote state. So we can say yes here, or I'm going to Control C out of it. It's going to remove the state lock. There we go. And I'm just going to go tofu init, and I'm going to say migrate state, which is the other way that you can do it, which basically kind of just saying yes to that. There. And it's going to migrate that out there. Now let's try doing that AWS S3 LS. And we actually have that file out there now. So our state is now out there in remote. If I do tofu plan, this is going to be grabbing state from the remote S3 bucket, which is exactly what we want. It's fantastic. We can even remove this Terraform TF state and TF state backup. In fact, if I move both of these files to just like temp to get rid of them, I move them instead of deleting. But if we move them and we go tofu plan, it's still going to work because we're not using the local state anymore. We're using the remote. And so you see how easy it is now. There's no excuses. There's no reason to not use remote state. Always do it. So, but let's say you have already existing resources from deployed. You already have an S3 bucket, and you want to bring it under management with OpenTofu. This is a problem a lot of people run into. They've just done ClickOps, and they've created a bunch of resources in the cloud, but they realize, hey, I should have been doing this with IAC, and so I want to start using OpenTofu to manage all of this stuff. What do I do? Well, luckily, OpenTofu has the ability to do this via importing. It's called importing. And we're going to demonstrate how that works. The other situation where importing is actually very valuable is in a situation where you've corrupted or deleted your state or somehow lost your state. And so that's the situation I'm actually going to create here, is I'm going to delete all of the state that we have, which I just got done telling you how vital it all is, but we're going to delete it so you can see exactly what it looks like to actually attempt to recover your state via importing, because this is also very much a break glass scenario. So we've already kind of saved our state elsewhere, but just in case, let's make a copy of it. And so I'm going to copy, there it is. I'm going to copy AWS just as a safeguard, and it was state.tf state. We're going to just copy that to something called backup.tf state locally, just so we have a just that we have a copy of it for emergency purposes. But the very next thing I'm going to do is something you should never, ever, ever do. Don't follow this except in just an example playing around sort of scenario. Never do this to your production environment. I'm going to delete that state file. Boom, it's gone. We've just removed our state. Additionally, I'm going to remove the things in our local configuration, which would suggest that state even could exist, which is going to be Terraform. Actually, that needs to be -rf. All of those directories, we're going to remove. I've already moved our TF state, or I've moved them to temp. The other thing that I have to do is I actually have to delete from our DynamoDB table, because there's going to be a record in there that actually has a hash of our old state. And so if I don't delete it, then the next time Tofu runs, it's going to be very confused, because it's going to say that the state appears to have previously existed and no longer exists. So I have this big command here that deletes the item. It goes to the table that we just created, and it's going to look for the item with a lock ID, which is what the state is right here, and it's just going to delete that record. So I'm going to run that, and we're done. So we've completely wiped out the state. So this would be the situation you're in if you ClickOps your way to a bunch of resources and you want to now back this into to an OpenTofu configuration. Now, the first thing you're actually going to need is a OpenTofu configuration that represents the resources that you want to manage. And so that would actually be, this, main.tf that we have right here. You would need to write out, the S3 bucket and the DynamoDB table and the resources that you want to import in and start managing. That has to be there to begin with. And so luckily we already have that. Now what we need to do is tell OpenTofu, hey, that remote resource that exists in AWS, I want to tie, for example, to this S3 bucket resource that I have declared. And so I want this to start managing that resource now. And so you do that with a tofu import command. And so we're going to start typing out tofu import. And what follows is going to actually be kind of specific to the resource. And so I actually have up the AWS S3 bucket resource documentation. And on all of these resources, if you scroll all the way down to the bottom, there's actually going to be a block on how you do importing of this resource. And so they have declarative blocks that you can use now. We're not going to be using that. We're using the CLI, which is right down here. And it will tell you when you want to import, and instead of Terraform, we just use OpenTofu here. OpenTofu import, you give the resource address, which in our case is going to be AWS S3 bucket.state, and then the name of the bucket itself that you want to go out and manage. And so let's jump over real quick to the code. I'll show you. So the address here is going to be AWS S3 bucket.state. And so let's do that. AWS S3 bucket.state. We're saying we want to import into that resource the bucket, which is named webinar OpenTofu on AWS. I need to run tofu init here. Whoopsie. Tofu init. I need to actually just get we deleted everything, so we need to get tofu back up and ready to run again. So now let's run that tofu import command again, and it should go grab that resource, pull it in. Exactly. So now that remote resource is going to be managed by OpenTofu, and specifically by that resource that we just had. So we're going to go do the exact same thing to the other three resources. And so luckily for all of the S3 resources, it's the exact same thing. You just give it the bucket name at the end. And so the other resource we had the bucket ownership controls. We're going to import that one. The other thing that we had was the public access block. So instead of ownership controls, we're going to go public access block. Access block. I think that was the name of it. There we go. So now we've done 3 of the 4. We've gone and taken the remote existing resources, brought them under OpenTofu management. The last one is the DynamoDB table. And I also know from looking up that one, which you can go check out the resource the documentation. It's going to be AWS. Well, we'll just copy it. I'll show you how you can kind of do this yourself. Is you would say, all right, I'm going to take it's AWS DynamoDB table. The name of it is lock. So we go in here, we say AWS DynamoDB table dot lock. And if you go check the documentation, it's just going to be the name of the table. And so we will go webinar, OpenTofu on AWS, lock, just like that. Because that was the actual name of the table out in AWS, and we've imported it. And so just like that, we've actually either you could say recovered our state, or if we never had it to begin with, we've taken existing cloud resources and we brought them under OpenTofu management. The real indicator here, if we've done it all properly, is if we run tofu plan and it's a no-op plan, there's no changes, then we're in good shape. And that's exactly what we have. No changes needed to the configuration. And so this kind of shows how you can either recover your state in case of emergency, or how you can bring existing cloud resources into management. Now, what you may say is, well, you had to already have all of that configuration pre-written. Like, we did kind of skip probably 80-90% of the work, which was writing those OpenTofu configurations, the S3 bucket, the configurations, and the DynamoDB table. If you have existing cloud resources that you need to convert into OpenTofu, got very good news for you. Our CEO, Master Driver CEO, Corey O'Daniel, actually did a webinar a few weeks ago on going from cloud to generating IAC. It was specific to Terraform, but the syntax of resources between OpenTofu and Terraform is effectively identical. And so I'm going to link a link to that in comments. I'm going to send. There's a that's the YouTube video if you want to watch. It's an hour long. He kind of goes through a few different tools. He also uses AI, I think ChatGPT, to try to generate the configurations. So let's jump back into the slides and let's talk about some best practices when you're doing OpenTofu in AWS. So from here, let's jump back into the slides. So if you want a full list of best practices, like I said, go check out our GitHub repo. There's a long list of it in there. But here's some highlights of what we've kind of gone over. One thing is when you're designing OpenTofu modules, well, first of all, OpenTofu modules is just going to be collections of resources. What we just wrote is technically an OpenTofu module. We just made 4 resources. It has inputs and outputs, which are variables and outputs. And it can be used standalone, or you can actually reference it like you're seeing here in all of these. You can reference an existing module and just say, hey, go and deploy all of the stuff that is listed in there. And you just pass in the variables like this, like CIDR block name and all this stuff is how you pass in the variables to it. So when you're writing modules, they should be fairly narrowly scoped to a single use case. It's really going to promote reusability and maintainability. So, for example, if you're making a VPC, an AWS network VPC module, you should put in the VPC and subnets and route tables and NAT gateways and internet gateways and all that stuff that makes a VPC work. But if you then want to deploy a database into that VPC, that should be a separate module. You shouldn't start putting your database or your VMs into that same network module. They should be separate modules. You can put them all together in kind of a monolithic module where you're calling each of them individually, kind of like what we have up here, where you have a VPC module and then you have a database module, and you likely are going to be referencing some VPC resources into that database module. That's how you should break them up. The reason is if you put all of them in the exact same module, and you kind of run into this with a monolithic thing too, you end up kind of increasing the blast radius, that one OpenTofu run is going to potentially touch dozens and dozens of resources that that you may not want. Like you may just be making a small change to the database, but you're going to have to go and kind of run a or an OpenTofu run against everything that's in that module, including the network. And you likely don't want to even accidentally touch the network when you're modifying the database. So keeping them narrowly scoped limits the blast radius of just OpenTofu runs. It also is going to tie the life cycle of resources together unnecessarily. So if you want to get rid of the database or make more databases or stuff like that, it makes that a lot harder if they're all just tied together into one thing, right? You have to start copy pasting instead of just managing them separately. It also limits reusability. Like when you're writing, one of the best things about OpenTofu modules is that they're reusable. You write it once and you can deploy it multiple times. And so you should be narrowly scoping your modules. You should also be encoding best practices into those modules. You likely don't want to just take every potential configuration parameter and expose it as a variable. That happens a lot in like the official modules, but that's because they're trying to make modules that work for everybody, which isn't great. You should be at your job, at your work, you should be making modules that are specific to your organization, that are narrowly scoped and encapsulate the expertise of what it means for your organization to run that piece of infrastructure. Okay. Second, you should be using remote state management, exactly what we just did. I went over that for a whole thing, so I won't belabor it anymore. But you do want to be looking for something, ideally even a platform that's going to offer you remote state management. If it can enable collaboration where multiple people can be using it together, keeping track of change and deployment histories so that you know when people executed it and why they executed it and what changed about it. Ideally, a user-friendly UI or GUI to make it easier for people who aren't necessarily familiar with OpenTofu to be able to execute. So like developers, allow them to be able to execute your OpenTofu. That's great. You want it to be secure and scalable. And there's a perfect opportunity for me to mention that right there is exactly what Massdriver is. It's a platform that offers state management. It's built for collaboration. We keep deployment histories and a friendly GUI to make it very easy to use. And so having said all that, what I am going to do is actually turn exactly what we just ran into a bundle. Really quickly, the last couple of things I'll say before we jump into bundleizing the OpenTofu we just did is you should also be storing all of your OpenTofu in source control, something like GitHub or GitLab, something like that. You should be managing it so that you can keep track of changes to it. And ideally, you should also be using something else to deploy, like Massdriver, to deploy your OpenTofu. You don't really want to be doing it locally. You can use things like GitHub Actions, like Azure DevOps, like GitLab, or platforms like Massdriver, which will allow you to execute OpenTofu, as well as numerous other IAC tools. We support Helm, we support Bicep. We're going to be releasing support for CloudFormation very soon. So let's jump back in and let's see what it looks like to execute all of our OpenTofu we just wrote as executing it as a Massdriver bundle. So in this directory, what we're going to do is run, actually, let's go up one directory just so we aren't dropping it in the module. Let's go mass bundle new. Now this assumes you have the Massdriver CLI locally. Okay, let's name it. Since this is really kind of a state store, that's what I ended up building this module for. Let's call it AWS S3 OpenTofu state storage. We'll call it something like that. That's going to be the name of this bundle, this module. We'll give it a description on S3 bucket and Dynamo DB. Let's capitalize the D in Dynamo. DynamoDB table for state storage of OpenTofu. There we go. That's the description. For the template, luckily we already have a template for OpenTofu. So we'll just say we want to use an OpenTofu module. We can then scan that OpenTofu module and look at the variables to make them presentable in the UI. So we'll say, yeah, go look at the OpenTofu directory because that's the code that we want to use. We only actually need a single input, which is going to be an IAM role. We need credentials to be able to deploy it. And it's going to be called AWS authentication. That's the standard name that we use for IAM roles. And yeah, output it to the master driver directory. Boom. That's all we need. So if we jump now into VS Code, we can see this new directory that we just made. It created this master_driver.yaml file here. You'll notice it imported those variables that we had, the bucket name and the region. You're going to see those in the UI. We also have the IAM role as a connection. The only modifications we really need to make here to this now are we don't even need the master driver provider. We are going to need the AWS provider since this is an AWS bundle. So we'll uncomment that. We'll also bump this to version 5. We'll update that in the template as well. And then we'll uncomment this block right here. Luckily, we're already set up to use var.region as well as the IAM or the AWS authentication. So this is now good. And all we need to do is let's just delete this main.tf. We don't need that main.tf. And we will just copy in. We jump into here and we'll copy OpenTofu main.tf. And we'll put that in the master driver source main.tf. So we're copying over the main. We can also copy over the variables. Although this is kind of a cool thing to see. We can auto-generate those variables for you as well. So if I cd in the master driver now, and I go mass bundle build, you'll see we're going to actually auto-generate the variables that are required for not only the inputs that we now have, but also you'll see the bucket name is here as well as the region. So we're ready to go. All we need to do here now is publish this bundle. So we will go mass bundle publish. This is publishing this OpenTofu bundle into master driver so it can be executed and deployed there. So let's jump over into master driver. I'm already logged in. I'm already on a canvas. I'm ready to go. If I now go open up the bundle sidebar and I search, hopefully we see that OpenTofu. There it is. AWS S3 OpenTofu state storage. That is the, let me make this a little bigger. That is the bundle that we just deployed. So let me drag it onto the canvas. Let's call it state storage, just like that. State storage. Adding it to the canvas. And now what we can do is we can configure it and deploy it right from here. So under config, you'll see we imported the variables that go into this OpenTofu. I'm going to rename this just so we don't have naming conflicts. We can deploy it into US East 1. That's just fine. If I click deploy, this is going to send it off to our provisioning system. And so this is going to execute the OpenTofu on your behalf. We're going to get back here momentarily. You're going to start actually seeing the resources coming through as it's getting ready to provision. As you remember, there were 4 resources. There was the S3 bucket, the 2 S3 configuration resources, and the DynamoDB table. And we should hopefully, see them showing up here in just a moment. There it is. So there's all 3 of the resources that need to be provisioned. And they're going to start executing and creating here momentarily. In fact, let's jump out of that. And let me show you some of the other things that we have on here. We keep a deployment history. So we have the one that's currently running. But if this ran again, we would keep track of it across time. So you could see all of the deployments that happened, as well as even being able to diff them and see changes that occurred to it. We keep track of the resources. I think it needs to be refreshed here. But all the resources that were deployed as a part of it. And so we try to make it very easy for you to be able to deploy and manage your resources that you deployed with OpenTofu. And as you see now, it is provisioned and it's out and running. So those resources now exist. And that's how easy it can be to run OpenTofu using master driver. The other thing is this is a very easy interface. And so if you're in a situation where you're trying to enable developer self-service, if you've built your OpenTofu modules or Terraform modules and you want to enable your developers to self-serve things like S3 buckets or SNS and SQS queues and be able to create them whenever you want or whenever they need without having to file a ticket, that's what something like this is great for. You can put in the guardrails around, variables and parameters. You can only expose the configuration they should be able to change and encode your best practices. And then anybody in your organization can just come in here, drag and drop, configure and deploy. And that's how easy it is to deploy IAC on Massdriver. So now that I have shamelessly promoted my product, let's recap exactly what it was. Oopsie, I actually reused this slide from last week where Michael did this exact same thing on Azure. So that AZTF export we didn't do here. But what we did do is we set up OpenTofu. We deployed resources. We talked about state files and why they are important and why you should always store them remotely. We then took a local state file and we transitioned it to being managed remotely in an AWS S3 bucket. We then obliterated that state and we showed how you can use importing to be able to take those existing resources and either recover state or create new state based off an OpenTofu configuration. We talked through some best practices in OpenTofu, particularly around AWS. And then we showed you how you can package up OpenTofu into a Massdriver bundle and deploy it through Massdriver. And so hopefully all of that was useful and valuable to you. So that concludes this webinar. Really appreciate you. How are we doing on time? Just in time with 5 minutes to go. So thank you so much for joining. I'm going to come off a webcam here, but I will be sticking around just for a few minutes. If you have any more questions, feel free to ask them in chat, and I will do my best to answer them. But thanks, everybody, for coming.